So Navisense is our computer vision solution from Sharp. Um, when I say computer vision, I will talk a little bit about what is computer vision. I do a number of these presentations, and usually when I ask the question in the room, how many people are familiar with computer vision? I get a few tentative hand raises. Some people might really know. Some it's kind of a mystery. So I like to kind of start a baseline with basically it's computer algorithms. We're just using computer and a camera to detect patterns in objects and turning that into data. So if you want to look at it in the simplest way, you take an image, and for humans, we have our eyes, and we can use our eyes to see that image. Computers have to use some type of sensing device. So in this case, it would be a camera. And the computer acts as the brain, where, for us, it's our brain. And we can draw on a lifetime of experience as human beings to determine what an object is or what an object might be doing. We start right away, as soon as we're born. Maybe some people say even before we're born, we're able to determine patterns in things. Computers don't really have that capability. They have to be taught every single thing and what it might be. So if I go to the next screen, so if you look at this picture here, a computer would interpret that as a bunch of different numbers with each pixel in the picture representing a number. And then we have to teach that computer what all those different sequences of numbers mean. And then in the end, it might spit out train. As humans, we look at it and go, well, that's a train. But it's not only a train, it's attached to something, and it seems like it sprang out of the side of a building. And it landed, and it looks like there's some people standing around it. And the picture's in black and white. And it looks like it happened a long time ago. I wonder how that happened. And we just go on and on because our brains are very powerful and we have context. So that is always the challenge with computer vision is trying to be accurate in determining what a picture is, and then maybe determining what's actually going on with that picture. And when we're talking really computer vision as we know it, we're not just looking at still pictures all the time. We're looking at video. So we're looking at many, many, many frames of pictures, going all the time. And we're trying to use computer vision in order to determine what those things are. The market for computer vision, this is all AI. The main things, facial recognition, object recognition, speech recognition. And you can see this is a very, very consistently growing market. Computer vision is interesting from the standpoint that, it allows us to have a force multiplier. You can't always have or hire enough people to do everything that you would want to do with vision. And an example of this is if you've ever been to a museum, I assume most people have been to museums. You might not have noticed that occasionally somebody is watching you in the museum. And if you look at what they're doing, they're standing there, they might have a stopwatch or they have their watch and they have a clipboard. And what the museum does is they hire people to watch guests looking at displays. And they want to know how many people are watching a particular display. They want to know how long they're there, because that's how the museum spends its money is the T-Rex going to be the draw? And are we getting a lot of people spending a lot of time in front of the T-Rex? Or is it this really, really interesting art display that is drawing the people? And you can't hire enough people to do all the data gathering that you want. Another example, my wife works for the Park Service, and they pay her to sit outside of trailheads and count the number of people that go in. And they count a lot of people going in and out of the trailheads, and sometimes she does surveys on them to determine who they are, why they're there. But usually it's how many people are they bringing bikes in? What kind of bikes are they bringing in? Where do they park? And that type of thing. And the Park Service cannot hire nearly the number of people that they want to do that they would like in order to get the data that they would like. With computer vision, you can solve some of those problems. Now, this is a pretty cool example that I saw recently in the newspaper. And this is in California, but I did a little research and there's another company doing this in Australia. So anywhere that you have sharks near beaches. And what they came up with was using computer vision AI tied to drones. So the drones are out cruising above the ocean near the beaches, and they're just taking video. And the video feed is being analyzed by a computer algorithm. And when it sees a shark, it alerts somebody that there is a predator in the water of some size. Now, the one I saw in Australia is actually going a little further, and it is identifying the type of shark that it is. So is it a bull shark or a great white shark? So what they've done is they've taken an algorithm that could determine maybe a fish, maybe it starts with this is an outline of a fish, and then they train it by showing a lot of images and a lot of video, and they teach it that, okay, this is actually a shark. And as you continue to train it more and more, you can refine it and say, okay, this is a particular kind of shark based on its fin structure and how it swims. So it's pretty interesting. And as we like to say, you're pretty much limited by your imagination on what you can use computer vision for, because literally just about anything that the human eye can see, we could detect with a camera and use a computer program to identify what that might be. So it's pretty exciting stuff. Um, Navisense itself is our our program that we developed over the last few years. And we started off with a few goals. We originally had about 5 years ago a very retail-centric type of computer vision solution. And the idea at that time was, well, we want to look at things like age and gender and do real-time content triggering based on age and gender. So as a middle-aged guy, I walk in front of a display and the camera picks me up and it throws out some sweater that I might be likely to like, maybe triggering a buying impulse. When I tell people that's what I was doing, they thought that was kind of creepy, that the cameras are watching them and putting up advertisements. And there are a lot of companies that are still doing that. But we found, as we were talking with customers, they were very interested, more so than triggering content, they were more interested in discovering who was in this space, how long they were there, were there peaks and valleys in attendance, or how long they were waiting in line. So kind of basic things. So we revamped what we were doing, and we wanted to make something that was cost effective, that was fairly easy to get going. Because when you think about computer vision and you think about, well, what am I going to do with all of this? I'd like to know everything that goes on in the world in my retail store or my bank or whatever it happens to be. But and you need to start somewhere. And usually that somewhere is counting people. So we wanted to make it easy to get into that and show results and then be able to grow from there. So we have a number of different algorithms that we can do, such as the people watching and other things that I mentioned, but I'll go through some of the other ones. And we wanted to be able to deploy on a number of different computing devices, from Raspberry Pi, Intel Smart Display modules. These are both things that are within some of our displays. So we have Raspberry Pi slots. We have computing slots for Intel Smart Display modules. We wanted to be able to put it out on Intel servers because pretty much all our customers have Intel servers that they use, or in some cases out on the cloud. And we wanted to be able to, for most of these models, utilize existing camera equipment if we could and cut down on the cost. And we wanted to make it really simple for our customers to be able to get that data and put it in their own dashboards. Now, our original product that we had had a very beautiful set of dashboards that you could use, and they were Power BI dashboards. You could slice and dice in many ways. And pretty much all of our customers, without exception, at the time said, those are beautiful dashboards. Can I change this? Can I change that? Can I just get the data? So when we redesigned, we went with this approach of we just wanted to make it so that you could get at the data and put it in your own dashboards, whatever those might be, or use some other type of analysis tool, whether that's Excel or Power BI or any other type of analysis tool. And again, you can leave it on the local server, or you can put it into the cloud, wherever you want that data to reside. We did very well with this. So we brought out the product, and immediately, I think we introduced it a couple of years ago, 3 years ago now at InfoComm, just as an early incubation project. Really, our goal with this was to bring it out and in a common sense way, find customers that knew they were going to be working with something new, and they knew there were going to be some hiccups along the way, but they were really interested and wanted to give feedback and help us build this. So we brought this out, and we won a number of awards that year, and we won a number of awards the next year. So by and large, I think one of the big reasons we won awards with it was we were using live product. So we actually had it running there. That was part of the previous presentation, is it's not just slideware. It actually exists, and you can see it working. So this is a diagram of basically what I'm talking about. So a web camera married to a display that has integrated computing in this case, that is running a model of Navisense, and it could be any number of models. It could be people counting. It could be something like logos. So what kind of logos do people have on their shirts? It could be a camera that's facing out on the street, and it's looking at the types of cars going by, and it's counting the number of Mercedes versus the number of Chevrolets. And each time it does that, it timestamps and it sends that information to a database, and you can use REST API to export out of that database and then analyze that data pretty much with any type of tool. This is an example of our very simple graphical user interface. So here it just is, how you turn it on. This is actually our executive briefing center in Downers Grove, Illinois. And if that was a live shot, when people walk by, you'd see little boxes going, identifying them as a person as it goes by. One thing I would say is we are not doing, at least at this point, facial recognition. Because of the nature of facial recognition. In some states, such as Illinois, they take a dim view of capturing people's images and identifying them outside of security purposes, like in airports. Now, we have been asked by our partners if we could do facial recognition in the case of opt-in. So if you went into a sports arena and you were at the suite level and you had opted in and said, yes, I'm willing to use my face to get rewards for doing so. So and to be identified or get easy access. In that case, we can do facial recognition. But for the generally available ones, we are not doing facial recognition. This is a few examples of some of the use cases that we have. The aforementioned people counting, dwell time, people wait time, and dwell and wait are different, right? So dwell, we look at it as people in a group, how long they're standing around in that group, maybe in front of a display or something like that. Where wait time, we look at it more as queue time. So if you have, for instance, at a stadium, you have 40 people lined up in a hot dog line because it's between innings, and the system can see that and it can trigger on a display. There's only a 5-minute wait, 2 lines down, something like that. And what we're doing is we're applying an average of wait time for the people in that line. We can also look at a paralogo. This is interesting for retailers that want to know, especially things like Under Armour or Nike. They want to know, well, I've got a Nike store. How many people are coming in wearing Under Armour? And if I see people with Under Armour, do I want to maybe start putting out content on the displays to entice them to buy Nike, as an example? Vehicle count classification is another really interesting one for parking ramps and for parking lots at sports venues, could be at malls and the like. We have airports that are very interested in that. They want to know what types of vehicles are coming in. Are they Mercedes? Are they BMW? Are they Chevys? Because they sell advertising within the airport, and they want to be able to entice those companies by being able to show metrics on the data that is gathered. And vehicle wait time. Of course, we all sit in our cars and wait for things, but like at a bank is a good example of that. Are some of the vehicle wait times at the drive-through getting long, and do we need to bring more tellers open? So uh, this is a project that we have recently done down at Charleston Airport. This is an interesting use case where they wanted to know the size of bags. And they were interested in being able to tell customers early if their bag should be checked or if it could be used as carry-on. And I'm sure any of you who travel have been on a plane and you've seen someone come on the plane and they have an enormous piece of baggage. And your first thought is that's never going to fit in the overhead. Your second thought is, I wonder how they got that through TSA. And because it would never go. Well, TSA, as long as it fits through that X-ray machine, they don't care. You just slide it on through. The airlines care because that person slows down the boarding process. So Charleston has put in kiosks with Navisense, and they're using DV-LED in these nice kiosks. And when passengers come up, the little pinhole camera sees their baggage, and it will then put a message up, and it will basically show a box around that piece of baggage, and it will suggest they check that piece of baggage and save time. Now, as we go along with the project, what they want to do is tie it into the TSA lines, and they want to encourage people by showing how much time they can save by pre-checking their bags. So that's a pretty cool project. And from that, and this actually was the POC for the project. So we were just using overhead security cameras just to feed. For something like this, you ideally want the camera a little bit lower so that more like the luggage height or a little bit above, so that you can get a good idea of the metrics around it. Above and from a distance is kind of difficult, but they were really impressed with how accurate this turned out to be. And we'll see if I can, yeah, that works in the window. So you can see it's looking at the larger luggage. It's saying it's check-in. It's identifying that persons are walking by, and for little backpacks and that, it'll sometimes say carry on. The interesting thing about this is previous to this, you would have had to use stereoscopic cameras to try to figure out the size of baggage. And part of what we did with our developers was work on algorithms that could just use a regular camera. And in this case, it's a security camera, or we're using a very, very small web type camera in the kiosks. So it didn't require any super expensive cameras to do. Where we're going with this now is they are progressing on to wanting to understand a number of facets around when planes depart and enter into the gates. Because essentially airports are like hotels. When you check in with the plane, you're on the clock, and as soon as it pulls away, you're off the clock. So they want to be able to gather this data so that they can show the airlines what exactly is happening. So this will be 14 models looking at 14 different things all around a plane arriving. So when wheel chocks are behind the wheel, when the jet port comes across and connects, when the fueling cart comes around and connects to the plane, when the luggage cart arrives and luggage starts to come off. So these are all things that they want to be able to gather metrics on, and we are entering that phase of the project now. So I think that's a pretty exciting project, and really applicable to a lot of different types of use cases. Any of these, whether it's the people counting or baggage or dwell time, wait time, apply to a lot of different types of industries. It could just be not even baggage, but is baggage in the right place? Or is there an unattended bag somewhere from a security perspective? We have a lot of use cases that are around, security. Fire exits are things blocking fire exit doors, or things in loading docks are pallets stacked too high. Safety equipment are people wearing hard hats or vests. as I said in the beginning, pretty much anything. We have really cool use cases for medical, for like fall detection. So if a patient or someone has fallen in a hallway, or if there's camera access to rooms or ERs, if they've fallen in there, we can immediately alert on that. We can alert on patterns that people might be doing, such as fighting. And this is something that we see in higher education as a good use case, or even in stadiums. You can't have people in security everywhere all the time, but if the camera's just kind of always looking out at the crowd, it can see if there are people that are doing motions that would indicate fighting, and then we can send a text alert to a resource officer or security. So, as I mentioned, pretty much anything that you could conceive of. Now, I am set up here to try to do a little demo of kind of the submodels we use. So, and I think I have a few minutes. I'm going to give this a shot. I'm going to try doing this on the same computer as I am doing this on, and we'll see what happens. I don't know if it'll let me and also show my face at the same time, because it's going to be trying to use the camera, but we're going to give that a try. Maybe I have to stop my camera so we can take it over.
So far, we see your face and a still of the gate operations slide.
Okay. Yeah, let me see. I'm gonna try turning my camera off for the meeting and seeing if I can start the program, because the program is going to be using my desktop camera. Interesting. Maybe if I turn that one off, that'd take me off screen.
It looks like it's just two still pictures of the jet bridge connected and the jet bridge being removed from the aircraft. That's the slide we see.
Okay. Oh, hold on. I think I just made progress.
Okay.
Okay, we're gonna try. I'm gonna try sharing again. I'm just gonna try sharing my. I'm gonna try sharing my screen, and you guys should see a choppy video of me.
We do.
Hey, that worked. So there's a little lag, because right now my computer is doing multiple duty of trying to be on this Teams meeting and do computer vision. So you can see there's a box around me. It's identified me as a person. It sees that I have my office potted plant back there. I'll try a few objects that I brought with me here. Let's see if it's gonna. Oh, you have about a 80 to 90% certainty that that's a cup.
Wow.
Cell phone. It's very sure that's a cell phone. Got a bottle there. I saw one of my dogs walk by. We pick up the dogs. I actually had someone once ask me if we could do a model on bears, because bears would wander into their store. And I said, okay, where are you guys located? And apparently that was up in Alaska. And bears would come in the automatic doors and start wandering around inside their stores, which would be a frightening thing for anyone.
What's been the most interesting error so far?
What's that?
Have you had any interesting errors?
Oh, and as far as
the detection.
The detection? I don't know if we've had interesting errors. You know, we were doing No, well, you stumped me with that one. I'm trying to think of something that is really interesting. I will say that, you know, for some things, like sometimes it'll say this is a bird, and sometimes it'll say it's a person. But I'll use this as an example. So it kind of, okay, there we go. It likes this side of the bird. Now, these are just raw algorithms. So these they're in a set that's called yellow. So it's trained for like several hundred different objects, and it can basically identify them. Now, if we were to take this object and we wanted to do something interesting with it, maybe for Audubon, we would train this that knows right now it's a bird. We would start showing it images, and we would gradually train the program that this is actually a loon. And we could then start feeding it a lot of images of different types of birds. And the more that you do that, the more accurate the algorithms become. So that gets into your, your machine learning and other things. So I don't know that I'm still thinking if I will say someone I work with, I don't know what it is about her, but the baggage model really thinks that she is a carry-on bag. Early on. But and she hates it when I bring that up. And I won't say who it is, but and it's her hair. She has hair that comes down to the middle of her back, and it thinks it's a backpack, is what we determined it was. But the models have been refined since then, so I guess that was probably the most interesting one. And there's a couple of minutes left. I can stop sharing this. I don't have any more interesting items in my office, but it would pick up cars. I did do this at live at a place, and I had people holding up, like they pulled up a box cutter out of nowhere and started showing it, which I was kind of like, where'd you come up with a box cutter? And it thought it was a knife. So I was kind of impressed with it. So sometimes it surprises us with how good it is before it's even really been trained that well on objects. So I will stop sharing that. And I will just go back to my little camera feed here. I guess I got to turn that off. But in any case, I will ask if anyone has any questions.
Okay, thank you so much. This was very interesting. I especially enjoyed the demonstration with the object identification, especially just in its state of not necessarily being completely mature. It's pretty sophisticated. I do have a question here from someone in the audience. Can you touch on Sharp's approach to digital signage and how it differs from other display manufacturers?
Oh, wow. That was a completely unexpected question for me. I will say up front, I primarily work on software and software partners. However, we are, I came from NEC. So I was part of the NEC Sharp joint venture, and now I am fully Sharp. And I can't speak for all of the other display manufacturers, and I know there are a lot of very good ones. I think Sharp follows with what NEC's philosophy was, which was to produce very high quality displays that you purchase from a good company, and those displays last a long time. And when I've been out to places like Las Vegas, I've had other Sharp people with me and NEC people point at displays when we've gone into venues and said, "Oh yeah, they bought that one 10 years ago, and I see some display hanging up on the wall, and it still looks great, and it's been up there for 10 years." And there's a pride that goes into working for a company that produces that quality, and cares that much about its customers, that they still know who those folks are, and they still work with them. So from the actual product lines, I would say that we've really been moving heavily into adding computing resources to the displays. So you're beginning to see not just the slotted computing from Raspberry Pi and Intel display modules, but our newest line, our ME2 series, has Android system on a chip. And we have partners that are integrating with that, so that without having an external piece of hardware, you can have your CMS provider on that as well. And our direct view LEDs, aside from being gorgeous, you'll start to see those also having that integrated computing.
Thank you, Jody. And we do have more questions, but we don't have a ton of time. So we are going to move on to our next giveaway. which Sharp has generously provided this desktop monitor. So Jody, what I'm going to have you do, please, is select a number 1 through 120.
All right. Well, I was all ready for this, so I'm prepared.
Okay.
57.
57. Okay. Number 57 corresponds to Rick Schluter. Congratulations, Rick. You are the winner of this desktop monitor, courtesy of Sharp. Jody, thank you again. And it is now time for our next